Saludos mis gatitos, and welcome to this presentation on 90-degree geometric rotations. We'll be talking specifically about how to use the slope method to get new points once an object has been rotated 90 degrees. First, let's have a little review. We've looked at two previous types of transformations. The first one of those that we looked at was translations, and we noticed that whenever we translate a point or an object, all that happens is its position changes. In reflections, both position and orientation changes. And in both of these types of transformations, the resultant images are congruent with the pre-image. That is, the size and the shape are the same. Congruent means it's exactly the same. Maybe its orientation changed or its position changed, but its size or shape did not. Whenever you transform an object and nothing changes other than its orientation and position, that's called a rigid body transformation. In this presentation, we're going to be talking about a new transformation that we call rotations. In this transformation, the position changes, the orientation changes, but as before, the resultant image is congruent with the pre-image. It's exactly the same shape and size, and therefore it's referred to as a rigid body transformation. We need to get a little nomenclature out of the way. We have two types of rotations. On the left side over here, we have a counterclockwise rotation. The rotation will be to the left, and this is considered a positive rotation. On the right side, we have a clockwise rotation. It's the same direction that the hands in a clock move. It rotates to the right and is considered to be a negative rotation. In 90-degree rotations, there's a secret that makes these rotations easy to complete. And that is that perpendicular lines have slopes that are negated reciprocals. That is, if you have a slope of A over B, and you rotate that 90 degrees, that line 90 degrees, the slope becomes negative or the opposite of the reciprocal. Let's see what that looks like. So we have these two lines, and we'll choose a point on the line on the right-hand side in the first quadrant. And we're going to choose that point. And we're going to rotate that point about the origin. We always have to have a point of rotation specified. And in this case, it's going to be the origin. And here's the easy way to do this. We'll take the slope between the point of rotation and the point that we're going to rotate. In this case, that's going to be 3 over 5. And we're going to rotate it to the left. That's going to be a negative, it's going to be a positive rotation. And all we have to do is, from the origin, draw a line that has a slope of negative 5 over 3. So this was 3 over 5. The negated reciprocal is 5 over 3, negative 5 over 3. So from the origin, we'll count up 5. We're here, and now we count over 3. And if this was point A, this is point A prime. This point A had coordinates of 5, 3, and A prime has coordinates of negative 3, 5. You should note that if we did a lot of these about the origin, you would get this pattern. But for me, it's difficult to remember the rules like this. It's much easier just to remember all I have to do is take the slope on this side over here, negate it and invert it, and then from this point of rotation, just draw a line that has that slope. Let's say that our point of rotation is out here someplace. And we have point A, and we want to rotate it 90 degrees counterclockwise. The first thing that I'm going to do is tether these 2 points together with a line, and then I'm going to draw my slope triangle, and this is going to be 3, and the base is 1, 2, 3, 4, 5, 6, 7. So my slope is 3 over 7. And I'm wanting to rotate it 90 degrees to the left. So my new slope is going to be negative 7 over 3. So from this point of rotation, I'll designate it as point of rotation, I'm going to draw a line that has a slope of negative 7 over 3. I'll count up 7, 1, 2, 3, 4, 5, 6, 7, and over 3, 1, 2, 3. So this was up 7 over negative 3. That point is now A prime. And that's all there is to that. The easy thing about this is getting the slope and then creating a new line with the inverted reciprocal of the slope. And you're left with the rotated point. Now let's try this. Instead of just a point, let's do an object. I have this triangle. And I want to rotate it 90 degrees counterclockwise, and our point of rotation will be will be 0, 5. That's the point of the triangle that touches the y-axis. This will be point A. This will be point B. So from the point of rotation, I'm going to get the slope to point A, and that looks like it's 3/4. Now from the point of rotation, I'm going to get a negative slope of -4/3. So I'll count up 4, 1, 2, 3, 4. Count to the left 3, 1, 2, 3. That's A prime. We'll do the same thing with point B. Point B relative to the point of rotation has a slope of -4/2. Whenever I negate and reciprocate that, it becomes 2/4. So from the point of rotation, it's going to be up 2/4, and that's going to be that point. So now I have my triangle. Probably should have gotten a different color, but red works. There we go. So that's that triangle rotated 90 degrees. Let's put the points in. A prime is going to be, looks like -3, 9. And point B, that's right there, looks like that. Point B would be 4, 4,7. And the point of rotation was 0, 5. Note that since we specified that as the point of rotation, that it didn't move. Well, that about wraps it up for this presentation, and at the end of the day, there's only one thing left to say, and that is, that's all, folks. Thanks for watching, thanks for learning, stay safe, con cuidado.